3A Project, Momentum and Kinematics, Group 29. Question. A car is being tested for speed and crash safety. The car accelerates from rest towards a wall that is 250 meters away. The car reaches the wall in 10 seconds. The car hits the wall with a force of 7,500 newtons. What is the momentum of the car immediately before it hits the wall? Please pause this video and talk with the class. Here's the visualization. As you can see, the car is 250 meters away from the wall, and it takes 10 seconds to reach the wall with a force of impact of 7,500 newtons.
Inventory. We are given distance, which is 250 meters, time, which is 10 seconds, and v naught, which is 0.0 meters per second. We need to solve for acceleration, v final, mass, and momentum. Physics principles. We will be using the first kinematics equation, second kinematics equation, Newton's second law, and linear momentum.
Okay, so let's go through the solution. There are 4 steps that we're going to go through the solution, so let's go one at a time. The first step is to find the car's acceleration across the track. To do this, we're going to need the second kinematics equation. D is equal to v naught times t plus half at squared. V naught, of course, is initial velocity, and a is acceleration. We were given that the distance was 250 meters. We're also given that the initial velocity was 0 because the car was at rest when it first started. Because of this, we can just multiply that out times 10 seconds to get 0. Of course, half times 10 seconds squared times a is our variable for acceleration we were trying to find, will give us half times 100 seconds squared times a, which is equal to 50 seconds squared times a, which of course we can use in the next part, which is to find the variable a, which we'll use basic algebra for that. We'll just do 250 meters divided by 50 seconds squared to get us our acceleration 5.0 meters per second squared. That is the first step. Step 2 is to calculate the car's velocity given the acceleration. Well, we'll have to get the velocity at 10 seconds before it hits the wall. The final velocity is equal to v naught plus acceleration times time. V naught, of course, is 0, and acceleration is 5 meters per second squared. If we multiply 5 times 10 seconds, we will get our final velocity of 50 meters per second. Step 3 is to find the mass of the car in unit of kilograms. To do this, we're going to need the equation force is equal to mass times acceleration. Mass, of course, is our variable we're trying to look for. Acceleration is 5 meters per second squared, and force was given to us as 7,500 newtons. To do this, we're going to have to do some more algebra. Basically, we're trying to solve for m, so we're going to have to do 7,500 newtons divided by 5 meters per second squared, which will give us mass of 1,500 kilograms for the car. And finally, we have to find the momentum given what we know, which is the mass and the velocity of the car at t equals 10 seconds, of course. So the momentum at this point is equal to mass times velocity. The mass, of course, is 1,500 kilograms. That is what we just solved for. And the velocity from step 2 is 50 meters per second. Multiply those together to get our momentum of 75,000 kilogram meters per second. And even though significant figures is 2, we're going to simplify that to 7.5 times 10 to the 4th kilogram meters per second.
Incorrect answer. Incorrect answer A. 8.0 times 10 to the 4th kilograms times meters per second. This answer is wrong since the final answer was rounded incorrectly. Incorrect answer C. 7.5 times 10 to the 3rd Newton meters. This answer is wrong since the mass was multiplied by 5 instead of 50 during the calculations, and the units used are incorrect. The newtons meters are used for torque, not momentum. Incorrect answer D. 7.5 times 10 to the 4th Newton meters. Even though this answer contains the correct numerical value, it again is wrong as it uses the incorrect units.